You're standing in line at the coffee shop. You check your phone. 9:17. You look up. You look back down. 9:18. A minute just vanished. You felt it go. You watched it leave. But here's what nobody tells you. That feeling, that sense of a minute slipping through your fingers, may be nothing more than a trick your brain plays on you. Physics doesn't care about your 9:17. Physics doesn't even agree that your 9:17 happened at the same time as someone else's 9:17. By the end of this, you'll understand why. And it might change the way you think about every single second you have left. Let's start with something that feels obvious. Time flows. You were a kid, then a teenager, then whatever you are now. Memories sit behind you. Plans stretch out ahead. It feels like you're on a river drifting from past to future. Every language on Earth bakes this idea into its words. We spend bit time. We waste a bit. We run out of it. Clocks tick forward. Calendars march on. The whole world seems to agree. Time moves, and it moves in one direction. But here's the thing. There's no law of physics that says time flows. Not one. There's no equation with a little arrow labeled "heart this way, please." That river you feel yourself floating on? It might not exist at all. So if time doesn't actually flow, why does it feel like it does? The answer starts in a place you wouldn't expect. It starts with a mess. Think about an egg. You crack it into a hot pan. It sizzles. The clear part turns white. The yolk firms up. Now try to uncook that egg. Put it back in the shell. Make it raw again. You can't. And that impossibility, that one-way trip from raw to cooked, is the closest thing physics gives us to a direction for time. Scientists call it entropy, which is really just a fancy word for disorder. Things tend to get messier. A neat stack of blocks falls into a pile. A drop of ink spreads through water. A hot cup of coffee cools down to room temperature. None of these things reverse themselves on their own. The universe slides toward disorder the way a ball rolls downhill. And the numbers behind this are wild. Take a simple example. One container of gas sealed tight. Let it expand to twice its volume. The disorder in that system jumps by a measurable amount. These numbers are so big they stop meaning anything in human terms. But they point to something profound. The universe has a direction. Not because some law commands it, but because mess is statistically overwhelming. There are astronomically more ways for things to be disordered than ordered. So disorder wins, every time. But wait, if entropy explains why time seems to point forward, does that mean time itself has a direction? Or just that stuff in time tends to get messy? This is where it gets tricky. Because the fundamental laws of physics, the deep equations that govern particles and forces, don't care which way time runs. You could play them backward and they'd work just fine. A billiard ball bouncing off a wall looks perfectly normal in reverse. So the laws are symmetric. They don't pick a direction. Entropy does. And entropy isn't a law in the same way gravity is a law. It's a statistical tendency. It's the universe playing the odds. So time's arrow isn't built into the fabric of reality. It's built into the math of large numbers. That's a strange thought, but the strangeness is just getting started. Now forget about entropy for a moment. Let's talk about Presentism. Right now, as you hear these words, you feel like you exist in a specific moment. The present. The past is gone. The future hasn't happened. This moment right here feels special. It feels real in a way that yesterday and tomorrow don't. But Albert Einstein wrecked this idea over 100 years ago, and he did it with a train. Picture two lightning bolts striking at the exact same instant, one at each end of a train platform. A person standing in the middle of the platform sees both flashes at the same time, simultaneous. Easy. But now picture someone sitting in the middle of a train that's speeding through the station. That person is moving toward one flash and away from the other. The light from the front bolt reaches them a tiny bit sooner. For the person on the train, the two strikes are not simultaneous. They happen at different times. And here's the key. Neither person is wrong. Both perspectives are equally valid. There is no cosmic referee who can say which events truly happened at the same time. Whether two things happen at the same time, what physicists call simultaneity, depends on how fast you're moving. And the faster you go, the bigger the disagreement. At 80% the speed of light, the disagreement between their timelines grows so large it becomes impossible to ignore. Two people at different speeds literally live in different nows. Your present moment is not the same as someone else's present moment if you're moving relative to each other. There is no universal now. There is no shared present ticking away for everyone in the universe at the same rate. So if there's no shared present, what does that do to our picture of time? If now depends on your speed, then every moment is just as real as any other moment, depending on who's asking. This leads to one of the biggest debates in philosophy. Two camps, two very different views of reality. The first camp says only the present is real. Yesterday is gone. Tomorrow doesn't exist yet. This moment, this breath, this heartbeat, that's all there is. Philosophers call this presentism. It matches how life feels. You can't touch yesterday. You can't grab tomorrow. Only now seems solid. The second camp says something much stranger. It says every moment, past, present, and future, exists right now. All of them. Equally real. Equally solid. Like pages in a book that are all printed, all bound, all sitting on the shelf, whether or not anyone is reading them. The non-present is just whichever page you happen to have open. This view is called eternalism, and it leads to what physicists call the block universe. Picture a loaf of bread. Each slice is a moment in time. The whole loaf already exists. You don't bake new slices as you move forward. They're all already there. Your sense of moving through time is like dragging a knife through the loaf, illuminating one slice at a time. But the loaf doesn't change. It just sits there, complete from first slice to last. When physicists were surveyed about this at a major conference, 65% leaned toward the block universe. 65% of the people who study this for a living think that every moment you've ever lived and every moment you will ever live exists right now, frozen in a four-dimensional block. But here's where it gets personal. If all moments exist, why do you only experience one at a time? Why does it feel like you're moving? Why does the present feel so vivid, so urgent, so uniquely real? The answer might be in your skull. Your brain is not a camera. It doesn't capture the world in real time. It takes snapshots, and then it stitches them together into something that feels smooth. When a sound hits your ear, your brain doesn't register it instantly. The whole process takes roughly half a second, about the time it takes to blink. That's your natnaura. It's not a point. It's a smear. A half-second collage that your brain presents to you as a single, seamless moment. And within that window, your brain does something remarkable. It glues things together that didn't actually happen at the same time. If a sight and a sound arrive close enough together, less than the blink of an eye, your brain fuses them into one event. Clap your hands in front of your face. You see the clap and hear the clap at the same time. But light travels faster than sound. The signals arrived at different moments. Your brain decided they belonged together and merged them. So the present isn't a moment in the universe. It's a construction in your head, a neural edit. Your brain takes scattered signals arriving at slightly different times, stitches them into a coherent package, and hands it to your conscious mind with a label that says EMS now. But if the block universe means all moments exist, and your brain constructs the feeling of NAS now, then what is time's flow? Maybe it's this. Entropy gives the universe a direction, a statistical slope from order to disorder. Your brain rides that slope, collecting signals, building a present, creating the illusion of movement through something that isn't actually moving at all. Flow isn't a property of time. It's a property of consciousness navigating a static landscape. Now, there's a serious objection to all of this, and it deserves respect. Some philosophers argue that the flow of time is not an illusion. It's as real as anything else in physics. They point to lived experience. You age. Causes come before effects. You can remember the past, but not the future. These aren't just feelings, they argue. They're features of reality itself. Maybe physics is missing something. Maybe the equations are incomplete. Maybe there's a genuine namar becoming that no block universe can capture. And they have a point. The physics of tiny particles includes strange events. Moments where a particle seems to snap from many possibilities into one definite state. Some physicists think that snap marks an objective present, a true naman naud that the block universe can't explain. But here's the catch. That objection only works if you assume your lived experience is a reliable guide to the structure of reality. And we know it isn't. You feel the Earth standing still, but it's spinning at 1,000 miles per hour. You see solid objects, but they're mostly empty space. Your senses are built for survival, not for truth. The feeling of flow might be just as misleading as the feeling of stillness beneath your feet. And there's a domain where even the arrow of entropy wavers. At the tiniest scales, In systems with very few particles, entropy can briefly decrease. A small cluster of molecules can randomly organize itself for a fraction of a second before disorder takes over again. The arrow holds on average across vast numbers of particles over long stretches, but zoom in close enough, and even the arrow flickers. The rule has a boundary. It works at the scale of eggs and coffee cups and galaxies. It doesn't always work at the scale of a handful of atoms. So where does this leave you? Standing in the coffee shop, phone in hand, 9:18 turning to 9:19. If this changed the way you think about even one moment in your day, there's a lot more at this depth on the channel. Drop a comment and tell me which part hit you hardest. I genuinely want to know. You felt that minute disappear, but maybe it didn't go anywhere. Maybe it's still right where you left it. One slice in a loaf that was always already whole.